In this video, we're going to look at what the z-score is, how to calculate it, and how it's used in statistics. The z-score refers to the number of standard deviations that the statistic is from the mean. If the statistic is higher than the mean, the z-score will be positive, and if it's lower than the mean, the z-score is negative. To show this, we look at the example. Let's say we have a population that has a mean of 58. Meaning it has an average of 58, and it has a standard deviation of 1.5. What are the z-scores for the two data values of 61 and 56.5? First, let's look at 61. 61 is 3 units more than 58. Well, 3 is 2 times 1.5, so 61 is 2 standard deviations higher than the mean. So 61 has a z-score of 2 or 2.0. Now the other score, 56.5, that's 1.5 units lower than the mean of 58. And 1.5 is equal to 1 standard deviation. But it's below the mean, so 56.5 has a negative z-score, and that is negative 1.0. Sometimes we have data values that when we subtract the mean and divide by the standard deviation, we don't get a nice whole number. So what we use then is the z-score formula, which is the data value minus the mean divided by the standard deviation. Let's look at a few examples. We have this same population with a mean of 58 and a standard deviation of 1.5. What are the z-scores for the data values of 60 and 57? For the data value of 60, we take 60 minus 58 and put it over 1.5 as a fraction like our formula says above. That simplifies to 2 over 1.5. We divide that out and we get 1.3 repeating, so we usually round that to 2 places. And we get a z-value of 1.33. Now for the data value of 57, we plug it into this formula. 57 minus the mean of 58 all over the standard deviation, we get negative 1 over 1.5. That divides out to negative 0.6 repeating. We round that to negative 0.67. Notice this formula gives us the correct sign on our z-score. Now here's how we use the z-scores. 68% of the data will be from z equal negative 1.0 to z equal positive 1.0, and that corresponds to this region in yellow here on this normal curve. 95% of the data will be from z equal negative 2.0 to z equal positive 2.0. That corresponds to this area including the red and the yellow. And 99.7% of the data will be from z equal negative 3.0 to z equal positive 3.0, and that would include all of the blue, red, and yellow area of this normal curve. Now furthermore, we can break down these percentages. From z equal negative 1 to z equal 0, we have half of 68%, which is 34%. From z equal 0 to z equal plus 1, we have another 34%. We can even break down the other regions of this curve. We're going to have a nice program that calculates these percentages for us when we put in the left and right z-scores. Now here's a simple example. Okay, going back to our example with a mean of 58 and a standard deviation of 1.5. What percent of the data has a value from 58 to 59.5? Well, to do this, we have to calculate two z-scores, a right z-score and a left z-score. For the data value 59.5, we find the z-score. We take 59.5 minus 58, which is 1.5, divide by 1.5, and we get a z-score of 1.0. That's our right z-score. Now, at the mean, the z-score is z equals 0, because 58 minus 58 is 0 divided by 1.5. So we have a left z-score of 0. The percentage of data from z equals 0 to z equal plus 1 is 34%, and that's our answer. Now here's another question. What percent of the data is 59.5 or less in value? Now here our right z-score is 1.0 again, like we just calculated. The left z-score, however, there is no left value, it's negative infinity. So we use negative infinity for the left z-score. What that means is all of the data left of center will be included here, and that's 50% of the data. So we add 50% to the 34%, and we get an answer of 84%. And once again, we're going to have a nice piece of software that figures out these percentages. All you're going to have to do is calculate those left and right z-scores and plug them in. That'll be the next thing we do. Now let's look at an example where we use this z-score tool. It has all the percentages programmed into it. And the really nice tool to use is at this website that I have linked in the notes, and here it is shown up above here in blue. And to use this tool, all you have to do is figure out the left and right z-scores and plug them in, along with a few other values. So let's look at an example. Let's say we have ACT test data, and this is an actual example, by the way. It has a mean of 21 and a standard deviation of 4.7. What percentage of the scores are from 13.95 to 28.05? We find the z-scores for those two values. The left z-score is found by putting in 13.95 into the z-score formula. We get 13.95 minus 21, divide by 4.7, and we get a negative z-score of negative 1.5. We take the higher value, plug it into the z-score formula, and we get 28.05 minus 21, divided by 4.7 is positive 1.5. Those are the left and the right z-scores. Now, on the tool at the bottom, you're going to see a box like shown here. For the left bound, we put in our left z-score, negative 1.5. For the right bound, we put in the right z-score of 1.5. For the mean, we use 0 because the z-score is 0 at the mean. And for the standard deviation, we just put in a standard value of 1. Then you click on Calculate, and it gives you your answer. It'll show up as a decimal. Here it's 0.0866385. So we can conclude that about 86.6% of the data is from 13.95 to 28.05. And here I have a graphic showing on the normal curve what we have here. We have the percentage of data from negative 1.5 to positive 1.5. And those aren't nice even z-scores, so we need a computer or something to figure out those percentages for us. Here's two more examples using that z-score tool. For the same ACT data where the mean is 21 and the standard deviation is 4.7, what percent scored 24 or higher? To do this problem, we figure out the left z-score. We take 24 minus 21 is 3. 3 divided by 4.7 is 0.6383. That's our left z-score. Our right score is positive infinity, which we write as plus INF. We plug these values into the calculator. We put 0.6383 as our left z-score in the left bound. We put plus INF as the right bound. Again, we use 0 as the mean and 1 as the standard deviation. Click on Calculate, and we get 0.261639, about 26%. And here I have a graphic that shows from the left z-score of 0.683 to positive infinity, we have about 26% of the data. So 26% scored 24 or higher. The next problem I have here is what percent scored 23 or lower? Here, 23 is our right z-score. And to figure out the z-score for 23, we take 23 minus 21 is 2. 2 divided by 4.7 is 0.426. That's our right z-score. We put it in for our right bound. Now, the left z-score, well, it's to negative infinity, so we use z equal negative infinity, or we abbreviate it minus INF in our calculator. Then we plug in 0 for our mean again and 1 for our standard deviation. Press calculate and we get an answer of 0.06649 and more decimals after that. Rounds to about 66.5%. So we see that 66.5% of the data was 23 or lower in score.